Section 5.3 is solving systems of equations by using the method of substitution. So first, some vocabulary for you. Consistent means there are going to have solutions, and an example would be if we had intersecting lines. So yesterday when we looked at graphs, those are consistent because they intersected. Inconsistent ones meant they were parallel lines because there was no solutions. Sometimes when we are doing our algebra here, we may run out of variables. They may cancel out. So if that happens and we're left with a true statement, we are going to have infinite solutions. If it leaves a false statement, we will have no solutions. And I think we will get a hang of those as we do some examples. So example A, step 1 is to solve one equation for one variable. Well, we've got that one set in here because I just have a y equals. So step 2 says substitute, so you have one equation with one variable. So what I'm going to do is if this is what y equals, I'm going to substitute that into my first equation where y is. So I'm going to have 6x plus 12, but instead of y, I'm going to put in my entire boxed area here. Okay, so whatever y equals, you're going to put into the other equation for y. Okay, and then step 3 says to solve. So at this point, I would distribute. So I'd have 6x minus 120x plus 24 equals 5. I would then probably put my x's together. So I'd have negative 114x plus 24 equals 5. I would want x by itself, so I would subtract 24 at this point. So I'd have negative 114x equals negative 19. And I would divide each side by negative 114. So I get x to equal 1/6. Okay, so now I've got the x-coordinate, but yesterday, just like we were talking about, these intersect at an ordered pair, which means I also need my y value. So step 4 is to substitute that back in, and I'm going to substitute it back in to this second equation because I just had my y equals. So I'm going to say y equals negative 10, but instead of x, I now know that my x is 1/6 plus 2, meaning my y value is 1/3. Okay, but again, all of our answers need to be ordered pairs, x, y. So I've got 1/6, comma 1/3 for my final point of intersection. Obviously, that would have been a little harder to do yesterday on the calculator with these fractions, so that's why sometimes using the algebraic solution is nice. Example B, okay, so I have one equation set equal to one variable, so y equals 4x, so then I'm going to substitute that into my second equation for y. So I've got x, instead of y, I have 4x equals 36. Okay, well, x times 4x is 4x squared. Be really careful there, okay? It's not 5x, it's 4x squared. Next, be really careful. We have to divide by 4 first. So I get x squared to equal 9. Well, to undo a square, we square root it, and that gives us two options, 3 or negative 3. Okay, and you're like, why? Well, negative 3 squared is also a positive 9. So you can have two answers here. Okay, this might be a spot I highlight, I make a note here, but you can always have a plus or minus when you square root a number. Okay, so now I need to find my y value. So I know that y equals 4x, so y equals 4 times 3, which is 12, or 4 times negative 3, which is negative 12. So my ordered pairs are either 3, 12, or negative 3, negative 12. So I have two answers here. Okay, so we'll try another one. We'll take a look at example C. Example C is a little trickier because I don't have one equation solved for one variable. So what I need to do is rewrite one of those equations. So I have either just an x equals or a y equals. It does not matter which one you pick, so I would suggest whichever one algebraically would be the easiest to solve. So if I look at my first equation, that's just a y by itself without a number in front of it. So I'm going to solve for y. So I'm going to add y to each side here. So I'd have 2x equals 9 plus y. And then I would add 9 to each side. So this would be y equals 2x plus 9. Okay, so I solved that first one for y. And now, just like before, if this is what my y equals, I'm going to substitute that in to my second equation for y. Okay, be careful not to plug it back into your first equation, always the other equation in your system. So I'm going to have 3x minus 8 times, but instead of y, I have my new expression, 2x plus 9, and that equals negative 7. So now I'm going to solve for my x by distributing. Watch carefully, you are distributing a negative 8, so that's negative 16x minus 72 equals a negative 7. So I'll put my x's together. That will give me a negative 13x minus 72 equals negative 7. I'll add my 72 next. Negative 13x equals 65. Divide by negative 13, so x equals negative 5. Again, I need to get my x and my y, so I'm going to plug it back into the expression I found over here. So 2 times negative 5 plus 9 means my y value is negative 1. So my final answer is an ordered pair, x comma y. So negative 5, negative 1. Okay. So looking at example D, again, we want to see if we have one equation set equal to one variable, and we do. So our first one is our y equals. Okay, so I can plug that into my y right here. So I'm going to have x over 3 plus 2 times, but instead of y, I have the 6 minus x over 6, which equals 12. So again, I'm going to distribute. So I've got x over 3 plus 12 minus 2x over 6 equals 12. Okay, so remember this is just 2 over 1, so when I multiply fractions, I multiply straight across. Well, 2 over 6 happens to be the same thing as 1 over 3. So now I have 1x over 3 minus 1x over 3. So those cancel. So now I have 12 equals 12. Well, this is what I was talking about in the notes earlier. Sometimes our variables cancel, and we're left with a statement. So then the question is that true or is that false? Well, 12 does equal 12, so that's true. So that means my answer is infinite solutions. Okay, what that means is those two equations represent the exact same line, so these are actually overlapping lines. Okay, all of this was two different ways to write the exact same line. So this is the same line, okay, or overlapping lines. If I ever asked you to describe what that meant, you would tell me that's what the graph would look like, and this is the number of solutions, which is infinite. Okay? And then one story problem, because we love story problems. At Perfect Pets, a starter aquarium kit costs $15 plus 60 cents per fish. At Gills and Frills, the same kit costs $13 plus 80 cents per fish. For what number of fish is the cost the same? Okay, well, if I said the cost for the first one was $15 plus 60 cents per fish, okay, the per fish means that's the one that gets my variable, that's my slope. And the second store, the cost was $13 plus 80 cents per fish. Okay, so the per fish, again, is the one that gets the x. So now I've got my system of equations, so I know that c here can go into my c down here. Okay, so you're always plugging it into where that variable is. So I've got 15 plus 0.60x equals 13 plus 0.80x. So to solve for x, I would want to get them together. So I would subtract 0.6x from each side. So I would have 15 equals 13 plus 0.2x. And I get rid of my 13. So I would have 2 equals 0.2x. Divide by 0.2, so x would equal 10. Okay, so it would be 10 fish. If I wanted to know the cost, I would again plug that back in. So I'd have 15 plus 0.6 times 10. So that would be 6. That would be $21. Okay. All right, that's all we have for substitution today. Go ahead and write down what you're confused about or what you have learned and bring those to class tomorrow.